Okay, right. Assalamualaikum and very good morning. I hope you guys, everyone in a good health. So for today, basically I would like to talk about introduction. Okay, all right. Let me set this first. And introduction. And introduction to machine learning. Okay, so this will be the chapter number 3. If you take a look at here, I think most of us familiar with chapter 1 and 2. I think this will be the kind of introduction. Okay, and then where am I? This one is fuzzy, right? The one that we discussed last 2 weeks, and this time around is this. So in this particular topics, basically we will talk about several learning types, okay, under the roof of machine learning. So I was talking about that, I think. Okay, right. So this will be the content for our today's lecture. So I hope you guys can see it well. All right. Okay, then first of all, I would like to introduce the definition of machine learning. So this will be the one. And then the problem that has been triggered the machine learning to be evolved as a kind of field, important field in the artificial intelligence subset. So this will be talk about many problems in machine learning. And we will talk about the real example and real application on that matters. So then we will compare and try to differentiate between two things. So the idea of talking about traditional program versus machine learning approach, if I may say. Okay, right. So the traditional program means that I think most of us familiar with. So for example, we have on the codes that we have, example import from, and then we have print hello. Okay, so for this purposes, basically the instruction write a word, hello, by using Python code. All right. So basically, the traditional program approach, basically, we require us to put things in script, right? Okay. So then we write it and we execute it via the editor and compiler, right? So this one. So meanwhile, in here, so basically, the output is happening at the end. So while here the machine learning is new things to be discussed soon. Okay, so it's not really matters about the one that we construct the program at first and we gain the output later. So however, it will be using the output in the program and having something at the output. So for the machine learning. Okay, then we will talk about the ideas of what we have in the learning types in machine learning itself. So speaking of which, I think we did discuss about the artificial intelligence when we first met in this class. So the under the roof of artificial intelligence, basically we have what we have machine learning underneath of that, right? So we have this one. So we did discuss this and this and this and this basic. Then in the artificial itself, there will be many, okay, things to be considered: X, Y, Z, and A. So one of those is machine learning. So then, if we go deeper in machine learning itself, so inside the machine learning there will be a deep learning. So this will be the kind of things to be discussed for in the subject. So not to forget that the deep learning over here, we do have many approaches. We do have this. We do have many, and including the latest version of deep learning is called transformer. Okay, so hope you can follow me for by looking up to this slide. Okay, right. So first of all is definition of machine learning. So machine learning started as soon as 1959 by Otto Samuel. So he basically started to use the terms of machine learning over here. Okay. So he described that the field of study that give computers, okay, so a study, the keyword here, that give computers. Okay, now, so this will be the keyword over here, ability to learn. Alright. Then without being explicitly programmed. So meaning, this statement is came from the basic idea of traditional programming. So basically, we did write down the code we have over here. So basically, we will have the output, right, as hello. So that would be the traditional. So this statement saying that without being explicitly programmed. So meaning it's not really similar with the traditional one. So but the approach is against of this philosophy. Okay, opposite. So then later, it's quite far from that, but it must be something in the middle. So 39 years afterwards, Tom Mitchell described that the machine learning is the study of computer algorithm. So then we can see that the computer algorithm things coming that improve automatically through experience. So okay, right. So this will be quite important, guys. I try to change it to green over here. So this experience. Okay, so speaking about experience, meaning I think I mentioned earlier, as a baby, basically he or she has been born to the earth through the parents, and then the parent shows like an apple or like an orange or what else, banana. So we have things like that. So the baby is basically has learned many times by seeing things repeated time. So that's the thing, reflect to the experience, guys. Okay. So the machine learning is trying to imitate how human experience, see, and decide. Okay. So these are the things happen when we talk about human and goes to the neural network concept suggested, which has embedded underneath of the machine learning subset. So a computer is said to experience E, okay, and respect to some task. Okay, basically this would be the repeating again and again and again and again and again many times. So but task is, it depends on, okay, task is speaking of example in this particular field. Let's say we do have computer. So speaking of computer vision tasks, so we do have many things, guys, to describe. Example, we do have object detection, object classification, object segmentation. We have many things to be considered over here. So, and then every single this detection, classification, segmentation is considered as a task. So meaning those experience has been gained by the eyes and the human, or we can say that the computer vision is basically dedicated for that particular task only. So detection meaning, example, we do have an image of a human walking, so we can, the detection means this algorithm detected human is in or not. Okay, while classification is basically the touch between two things. For example, we did discuss about cat. This one is cat, is human. This one is dog. Okay, so the class meaning comparing these two kinds of object. So we class them to class A and class B. So that would be classification. While segmentation is whereby we can see the task when we talk about, let's say this is a man walking on the street. So there will be tree over here. So there will be bicycle over here. So in order to do that, okay, right, I change back to my in color red. So we segmentize this area is dedicated to human, this area dedicated to tree, while this one is to bicycle. So that would be segmentize based on the attribute that have happened in the selected images, guys. Okay, so that would be the idea. So then, after the experiencing, gaining the experience and respect to the dedicated task, so we did discuss about object detection, classification, and segmentation. So obviously, afterwards, we need to assess them, analyze by looking up the performance as a measurement. Okay, so that's what we call it TEP or ETP. So the one that we have in this slide, right? Okay. So for example, this is the very common and general example for learning approach. Okay, so we do have, say that we do have email program, okay, that watches which of our email which of our email we do or don't. Okay, so the keyword here is this one, mark as a spam and sorry, it's not this way. Sorry. That was not the deliberation for that. Sorry, salah. Okay, right. So the idea is okay, this one is the target for the class. Either don't spam or spam. Okay, so meaning email comes to our inbox, so then it reflects to us, we mark them as spam and not spam. Okay, so the idea is the program is basically watching us. So this is not a truly eye, this is the computer eye. Okay, looking to us, either we select those incoming email is basically spam decided by us or not spam. So that would be the idea of learning process. So we set the program, we set a task. This is a task, guys. This is experience, and this one is performance, right? So the task for this particular learning is basically deciding the email is spam, considering spam or not spam. Okay. So then we this program basically happened to be a specific task, deciding, and then experiencing. So experiencing meaning when we click those email, the example I do have info utem for today. So info utem is not spam. So I just click and not pressing the spam button. So meaning the program or the algorithm at the back of the email Outlook email, considering that we us is selecting this email to here. So one time. So then coming one email from BSN, promosi pinjaman pribadi. So then I obviously, that would be the idea. So meaning in the eyes of the Outlook email provider, seeing that us is deciding all this advertisement email is considering as spam. So they learn so many times. So it's not repeated only 1 to 2 times. But the thing is, they were looking up to many times. Many times. Okay. So then they have the experience to decide which one is which, right? So they will watch you to leveling up the email. The same goes to the idea when we have we talk about this company and what else? This company and I need to press it one by one. This company. So they are learning what we have chose and what we have watched through this stream, and then decided which video is available for us, right? So that would be the idea. So before they decide the algorithm, basically they have to be analyzing the performance in P. So they try to have come up with the, let's say this is the programming. So this is model number 1, this is model number 2, right? So say that the model number 1 is basically successfully describing the truth and not spam and spam email as 80%. So this one is 92%, for example. So obviously the company will choose this one, right? For the sake of customers' satisfaction, right? So meaning the more accurate the algorithm choose the email or the interest of some user, so basically the more likely what we call it truth of the decision making. So then people get to be like, oh wow, there are systems to suggest me to do this and this and this. It's kind of really relaxful. But the thing is, okay then, we go to the traditional program versus machine learning one. Okay, right. So I did talk about a bit briefing about the traditional program just now compared to the machine learning things. Okay, so the things that we have traditionally in the traditional program, we have data. Okay, what is data right just now? We pull the data hello as a string. Okay, so because obviously the hello is not how to say, it's not integer, right? So when we talk about integer, meaning I mean x equal 2.6 or something, that would be the numbering. Okay, so this one is string. So basically the HELLO has been sent to the kind of variable considered as a string, right? So then in the idea to get this hello written well at a piece of paper, okay, so basically we need to write the program, right? So this one is what we do have just now. And we do have what else, and so on. So then we do have the output. So eventually in this machine learning, the one that we have at the input side is the data itself, hello, and the output, hello. Okay, so that's what we are doing right now, because we are giving the output as our input back. Okay, so that will be learning process, guys. So meaning we give the experience many times, again and again and again and again. The output that we have, for example, when we give x1, we have y1. Okay, when we give x2, we have y2. So this is the input, so this is the output, right? So x will be going up to xn, and y also will going up to yn, guys. So meaning the more likely our training numbers going from 1, 2, 3, 4, 5, 6, 7, 8, and 9 and n. So basically the more intelligent the program is. Okay, so that what we try to say in machine learning. So meaning learning is going in and feeding this. It's not really talk about computer, guys. Later on we talk about network. This. Okay. Right. Okay. So far, is there any questions from the floor? Okay. Then we try to talk about the idea of machine learning just now, introduction. So what is the types which are available in the learning? Okay. So commonly, if you try to Google it up by your own, so there will be maybe 2 or 3 thoughts for describing this one. So one is supervised, the other one is unsupervised. That would be the one thought. So that would be the simpler one to describe the learning approach. So the other one is supervised, unsupervised, and semi. Okay, it's not called semi, but reinforced. Okay, learning. So that would be third. Okay, second thoughts. So the third thoughts is basically supervised, unsupervised, semi-supervised, and reinforced learning. So based on this idea, it is basically to take the third idea to pull up in this lecture. Okay, right? Because when we do Google it up in Google searching engine, so you might be saying that how to say, the set of learning is basically supervised and unsupervised for in this perspective of one author. So but to generalize everything, basically we try to put it up as 4 types of learning approach. So supervised. So okay, based on the word itself, supervised. Okay, supervised, supervision. So I think some of you are doing PSM, hopefully. So supervision is basically things that this one X is considered as student. So X0, X1 is lecturer. So meaning this X0 will be supervised by the student. So let's say, okay, X0, so please go this way, and please go that way, and please go that way. Okay, so during the PSM1, so basically 1/3 of the study is doing this way, and this way. At the end of the day, so basically we do have 3/3. So meaning complete set of a project which can be produce one pattern or one paper or one conferences or one product or whatsoever. Okay, right. So that would be the direction of supervision. So meaning, if we do have data, guys, supervised. So if we have data, the keywords over here is desired. So meaning the desired is came from. So this one is path A, path B, path C, right? So this direction is basically set by whom, guys? By supervision, this one. Okay, has been set by him or she, her, set by this and set by this, right? So same goes to the supervised learning. Say that we have 3 pictures. This one is human. Oh, sorry. This one is FIFA. Ni ball. Okay, this one is fish. Okay, so the idea of supervised learning is basically we set the class for each images that we have. Okay, so that would be supervised. So meaning the human. Remember the experiment that I did in class, guys, about the 4 faces of human. So I randomly selected 2 of the female students and 2 male student, and including me. Okay, 5 classes, can. So we do have at the end of the day what is the bar of performance, right? At the end. So that would be supervised learning, guys. Okay. So meaning I said this face is my face, Nick Muhammad Zarifi, for example, and the other face is Ain, for example. Okay, and the other face is Ezri, for example. So that would be setting by the person who in charge the programming or write the program. Okay, so that's the idea of desired. So meaning desired output level. So meaning this one could be A and could be B. So at the end we have 3 classes, guys, A, B, C. Okay. So however, For unsupervised learning, training data, so this one is simple as this, but no desired output. So meaning to say that, okay, right. Example, I do have two category of images, guys. This one is Messi, this one is Ronaldo, this one is what else? This one is Maria, Di Maria, and then okay, then this one is the ball for FIFA 2018. So this one is a ball for FIFA 2022. The type of ball has been designed by Nike or Adidas. So then I put it freely without. Then I mix these images, mix around, mix. So then the idea of this. So this images for the first on the left is basically over here. So speaking of the features X1 and X2. Okay. So then Ronaldo is here, Messi is here, Di Maria is here. And then the ball is basically over here, this ball over here, Qatar ball over here. So then, frankly speaking, from the we can see that this can be grouped together as the one considered as ball group. So this one is considered as player group. So without supervising, okay, no desired output. So meaning the data speak by themselves. Okay, that would be unsupervised, right? Okay, then semi-supervised meaning half-half. Okay, so the data and few desired input. Okay, so that would be some particular task. Okay, we talk about ETP right just now. So different task is different learning approaches methods. Okay, so while reinforcement learning is rewards from the sequence of action. So this reinforce basically happen in the robotics one, the one that we did discuss in the first few weeks in our semester. So example, this is the robot. So the first cycle of the movement is basically the strip, and we do have junction over here, we do have this. Okay, so right, so commonly the robot is going up to here. So then based on the experience, if we put some obstacle over here, so basically the robot himself is trying to avoiding this obstacle, guys. So it will somehow goes to this way if it could, and goes to this way, so avoiding this way, right? So basically the second time or the day after, we try the same robot, so we put the blocks over here. Okay, so the robot is trying to go here but cannot, so then it will go straight away. So based on the demand of the training sequence, okay, the data that has been collected day 1, day 2, day 3, so that will be enforcing that the learning will become better and better based on the rewards by the sequence, right? So this one is called, what we call it, sequence of action. So normally happen in robotics field. Okay, now, so type of learning. So we have, I think this one I've been discussed a bit at the first 2 weeks time. So the supervised learning, if I may say, we have two things: classification and regression. Okay, so class, as we discussed just now, we do have A class, B class, C class. Remember, this ball and fish. Okay, so we decide A to be human, B to be ball, and C to be fishes. Okay, so that what is coming, like the cases happen in classification is image classification of this, customer retention. Also we just change the images and input over here. So then this considered as the input dalam kotak. So diagnostic of what else? Example, the breast cancer of tumor images or retina. I think here retina images, iris, which detected the diabetism symptom or tumor that will diagnose the breast cancer or something. So that will be diagnostic purpose of things. Okay. Fraud detection, meaning the things that could be considered as spend, and so on and so forth. So not to forget that we have regression. Okay, regress. So this will be the kind of interesting. Okay, regression means it's not typically talk about the classes, guys. Now, okay, so we talk about value. Okay, so meaning, let's say it could be 2.5, 3.6, 5.9, or whatever. Okay, 99 is it minus 6. Okay, so but this one is depends on the images that has been given to the model in the training purposes, and we describe or we classify that image is belonging to A class, that image belonging to B class. But this in regression, basically we will have X, F, Y. So the training, as I mentioned earlier, the more that we train, YN. So basically the F that we have afterwards, after the training, is basically becoming an intelligent one. Okay, this one. So that would be example, giving that the size of iris retina, for example, or okay. So let's say we talk about house pricing in Melaka. Okay, so say that the price in Melaka, if we do have the size of 400 meters square, for example, so the range of the house is 200k. So 422 is 210k. So then we trade it until some extent 498 is 300k. So then this training basically happen to have a line, okay, estimation line. So later on we talk about this. I think tomorrow maybe. Okay. So the future input, if okay, let's say this is the training, right? So for the testing, basically, say that I give to this estimation as 429 meters square feet. So what is the estimated price? So based on the train fxy, basically this program can choose what is the price for that particular square feet range, right? So that would be regression, guys. Depends on numbering. Same goes to population growth prediction, estimation life expectancy, market forecasting, and okay, what they call it, currency upside down, and so on. Weather forecasting, that would be okay because of the weather is going up and down based on, let's say from now on we do have what they call it in Muslim scholar we do have full moon, right? So remember that the one that in our scholar, who knows white day, guys? Siapa ingat what day? What is the date for white day? 14, 15, 16 ke? 13, 14, 16, guys. Anyone remember? Supervised, reinforced. I think this one is unsupervised. So meaning the contra from the supervised learning. So this is basically clustering, the one that we did discuss just now. We don't know, we don't decide or we don't supervise the Ronaldo images as a player or Di Maria as a player, but we just put in the programming, and the programming decide itself by what they call it. This is the data, and this one is the other group, right? So that would be the clustering. Okay, cluster from one group, and one group. Okay. Right. Reinforce. Okay. Normally this one, I think more or less, where is my pen? Robot navigation, AI game. So this will be what we have. What is happening in what we call it, Dota. So we do have skill acquisition and so on, and real-time decision. So that would be like auto driving system, things like that. So then we try to discuss about, okay, supervised learning regression. Okay, we have the things that related to the house price prediction, okay, for regression. So regression is basically the one that related to X and Y. X and Y. X and Y. Okay. So learn a function. So the function is called as fx. Okay. to predict y by given x, guys. Okay, so means that the one that happened in the training, x1 y1, x2 y2, x3 y3, and so on and so forth until xn yn. So then the moment that we give a new x ni tak pernah dilihat oleh fx, so then the fx can give y value, okay, to us. So that would be the idea of regressions. Okay, right. So y is a real value, guys. Okay, means regression. Y is real value. So meaning the red line is basically regression 1. So this one is R2. Okay, so say that this will be the line has been fixed suggested by the regression line. So happen that say that the question came down 1,250 square feet. Okay, what is the expectation price? Okay, so means that based on this model, blue line, so the price is over here. But based on the second model, the price is over here. Example, so we do have two lines to be considered as a prediction for housing price. Okay, so then we know that the things related to value in y is known as regression. So supervised learning is right answer are given. So I think predict. Okay, so the other keywords is continuous value output. So example, I ask the system 1,250 square feet. What is the price? System. So the system tell me that the price is 275,000. Okay, so things like that. So because this is the continuous value. Okay, about the classification, guys. So I mean, the first one is regression, the second one is classification. So classification means the y is basically reflected to the class. Okay, so class meaning A or B, or 0 or 1, K or L, or something else. Okay, so meaning 2 classes, 3 classes, or something else. Okay, that would be the idea of classes. Okay, so so this would be the yes or no question for this particular malignant. Okay, malignant is basically the cells that been detected as this one for the breast cancer. Okay, so then this one is the probability of no cases for the breast cancer, and this will be the probability of yes cases for breast cancer. So however, truly this one is the size, let's say guys. So let's say this cell, this is the specimen happen to be as example 7 mm, this one is 8 mm, this one is 15 mm, this one is 20 mm, for example. So this one is 2 mm, so then this one is will be 3, and so on and so forth. So basically this line is comparing the things related to tendency to get the breast cancer or positive diagnosis as a breast cancer patient. It basically depends on the mm, but however in terms of number it's kind of difficult to judge. Okay, so that's the reason why this particular 2 mm size of the patient is okay. Oh, sorry. Are we good? Okay. Boleh tak seseorang tutup mic kamu, ada dengar kipas atau angin atas motor? Faik Danish. Okay, thank you. So okay, this is the idea of deciding the size of tumor reflected to the class, either yes or no diagnosed as a breast cancer patient. So that would be kind of thing. So remember, regression is the value one, and the classification is the category class, right? Okay, so this one is a supervised learning. X can be okay. So X can be multi-dimensional. So speaking of which we did just now, example, this is the tumor size just now. This is the one that we discussed just now is Y, right? 01. So the idea of having breast cancer and not having breast cancer. So that would be the one variable. Okay, so it can be multi-dimensional based on the feature. So just now is the size, right? For predicting the for diagnosing the patient. So but we do have also the other features and attribute that we have in the patient data. So the size of tumor, it could be age of patient, it could be occupation of the patient, things like that. So it's not limited to one dimensional features or attribute data, but it could be various of data itself. Okay, so meanwhile, if we have example, we have this data, guys, we have this data, we have this data. So say that it could be describable as this 3. Okay, so that would be shape and so on and so forth. Okay, so for speaking of unsupervised, is basically the one that we don't supervise themselves. They will be learn and try to group each of the group that they own to be by themselves. Okay, so speaking of which, we do have X, X2 and XN. So alright, hold on, I think this is not a good example. X1, okay, let me put it 1 here. Okay, right. So because this is 2 domains, but X1, let's say this is X11 is X11, X12, X13, right? X14. So this one should be X21, right? So meaning differentiate between the inputs for that particular features. So because this is X2, guys, this is X1, unless the slide will be okay if this is Y. Okay, so meaning the gist of the slide is basically trying to clustering all the data with the own group. They call it clustering, by the way. So this is the unsupervised data group individual by genetic similarity. So we can take a look at the idea of genetic theory by the unsupervised. So meaning each of this rectangular is basically described to be as owned by Hashim, for example, and this one is for Ain, for example, this one for Ezri, for example. So that would be that the genetic biasing on the clustering. Okay, so unsupervised learning is a crucial reason for using this particular approach. It's basically based on okay, if we have the unknown patterns in data. So the first one, it could be emphasized to do this if we don't have any information, any idea about what is the class in that particular data. So we don't do anything, especially the mixed data. Okay, unless we do have the segregate data. So for example, let's say I do have the data for, if you take a look at Kelantanis word study, I do have kanan direction, kiri direction, and others. So in my data sets, which I share with the all over the world, you also can use it. So the images is basically segregated, okay? Meaning classification. But unsupervised learning, meaning when we don't have this kind of any segregation of class. So meaning the data is basically all around one circle, mixed together. We don't have any idea of what it is. Okay. Then the moment we should decide the unsupervised, rather than if we are given the classes in our hands, so we don't have to use unsupervised. Okay. To find feature which can be utilized for categorization. Okay. So this will be the second statement. Find feature which can be useful in categorization. Okay. So this is happening when we don't have any idea about the pattern in data. So that example, kanan direction, kiri direction, we don't have any ideas. But when we throw the data to that particular learning strategies, so we see that the data is basically segregated in each of the cluster that we have. So let's say 4 clusters, north, west, east, and south. So meaning after we do understand the tendency of the clusters, so then we decide our categorization task for our next task, right? So that would be the importance of unsupervised learning. It could be step ahead before doing the true classification. Okay, so it is easier to get unlabeled data from computer that labeled data which need manual intervention. Okay, right. So speaking of unsupervised learning, it obviously unlabel easier, because when we talk about labeling classification, we need to label it. Okay, so before I set my data sets, for example over here, so the right hand side of the screen, so meaning I record the audio of Kiri by the human voice and I keep it in one folder, right? So meaning I need to label the image to be in that particular category. So that would be requires time and commitment to manual intervention. So without the unsupervised learning, we don't need this one. So we just put it in one folder, put 1079 images inside them. So then the program itself will be running and deciding the cluster. So that would be one important thing happen in clustering. Okay. So these are the component of machine learning. So I think based on our discussion, we do have the one that we talk about the numerical just now, regression, right? So we do have several regression types. I think we will be discussed on this tomorrow. Support vector machine, I guess we will learn also about the numerical. So all this idea is basically came down from XYZ in numerical. Probabilistic graphical models, naive Bayes and Bayesian network. So that would be probability. So meanwhile, this is considered as PX. Okay, probability is keberangkalian. Then optimization. Okay, so the moment that we talk about, okay, remember the TEP. Okay, what is P, guys? The third P. Anyone remember? This one is what is T? P is performance. Okay, so here the idea of searching the highest performance rate for that particular learning processes is basically we requires to deal with optimize. So here in P steps, we try to find the best. Okay, before we get the best, basically we try to optimize them. Optimize. So that will be optimization of that particular selected, what they call it, learning models. Okay, so we don't have gradient descent like in the perceptron and backpropagation algorithm in neural network. So square error, accuracy, and margin. So square error meanings, let's say, okay, next. Speaking of the house just now, we do have, what is the number? 429 feet square kan tadi kan? So saya ada 249K. This is the price, guys. So this one is the value that I give to that particular network model. So this is the estimation, guys. So but in reality, so 429 is not 259K, but 2500K. Okay. So the square error means the prediction minus this one square. So meaning 259K minus 250K square. So what is the difference between these two? So we have some amount, right? So then we talk about the next estimation value. Let's say 253 pula saya target tapi dia bagi 263. So meaning another difference, right? So square error meaning this error plus this error divided by the numerator of 2m. Okay, that would be square error evaluation. So we'll talk about this, I think, not next week, tomorrow. Okay. So speaking of accuracy, I think the accuracy depends on the how intelligently the model decide the class, and marginal. Margin meaning until what extent that the from 10 to 20, for example, that would be marginal. Okay. All right. Okay. All right. I think that's all for the introduction for what do you call it, machine learning. Okay, thank you guys for watching NMZH channel. Hopefully you can get knowledge and benefit from the videos. Thank you so much. Assalamualaikum.